Mitakuye Oyasin to all my relations. My name is Annette Lee. I'm mixed race Lakota. My communities are Ojibwe and Dakota Lakota. I'm speaking to you from the land we call Minnesota Makoche, the land where the water reflects the sky. This is the land, the original territory of the Dakota and later the Ojibwe people. I would like to just take a moment to also acknowledge that we're going through a really hard time, a COVID time, and there's a lot of loss that's happening. I'd like to send my prayers to all the people that have died and their families. With that, I want to welcome you to our event. This is Native Skywatchers, which is our Indigenous revitalization of astronomy and star knowledge grassroots programming efforts. And this event is very special because it's funded by NASA, NASA Next Generation STEM, and it's called Two-Eyed Seeing. And this is a special collaboration between Native Skywatchers, NASA, and the Maya Indigenous Astronomy team. So we have an action-packed show ready for you, but I also wanted to tell you that there are 7 events in total, and this one is in December, and there's one each month that's coming up. So there's the next one is in January, the Dene Navajo event. So the name of the event is Two-Eyed Seeing, NASA and Indigenous Astronomy for the benefit of all. So this comes from the teaching called Etuaptumumk, which comes from our Mi'kmaq elders. And it means to see with the best in one eye with Indigenous knowledge, and to see with the best in the other eye with Western knowledge, and to see with both eyes for the benefit of all. So this is a really important part of our program. I want to remind you, you can go on the website, nativeskywatchers.com, and go to the Maya page, project page, and there's a lot of resources that we've been working on. We've got a booklet, we've got the slides that go along with this webinar, we've got worksheets, and we'll have the recording of this live event. So with that, I'm going to pass it over to Gerado and Andrea. And I just want to say, I'm really proud and excited that we could create this together.
Dios botik, Annette. Thank you, Annette. I'm Andrea Medina, very honored to have collaborated with this incredible team. We've been working on this collaboration in Santa Barbara, California, which is native land of the Chumash, and we respectfully honor that we're on this land. We also honor all the indigenous communities that live on this land, like the Mixteco community, that were very happy and honored, participated with us as we put together this Maya astronomy event. One of the many inventions that the Chumash have is the tomol, which is a beautiful canoe that is used to go to the Channel Islands, and they used to have an incredible trading system, and we want to honor that. And we have envisioned the work that we've done together in the last few months as a way to trade knowledge on this land that unites us and connects us. So thank you everyone for joining.
Great. Thank you, Andrea. Thank you, Annette. This has been a lot of fun. It's very exciting to put this material together, and in particular to work with our first grade partners from Adelante Charter School. You'll be seeing them very soon. The idea that we have here is that we've broken up one big long story into a whole bunch of little segments, and we're going to be following through these segments with breaks in between for question and answer sessions. So if you get the chance, something just tickles the back of your mind, throw it down in the question answer, and we'll see if we can get to it during one of the breaks. The big picture that we're going to be telling you about is about Mayan eclipses. So we're going to try and get to a place where we can see a tracking of eclipses in a document. But we're not going to try and do it all in one hunk. We're going to take little breaks, and we're going to start off. Actually, we're fortunate to have a message from a partner of ours, a former UCSB student who then made it into space, NASA astronaut, Jose Hernandez. So we'll start this clip, and then we'll move through the rest of the content on our way to Mayan eclipses. So we hope you enjoy this, and please do ask questions if you have them.
Hello, native Skywatchers. Les mando un saludo, un fuerte abrazo a todos que nos están viendo. I'm hoping everybody is staying healthy and is practicing social distancing. And when you're going outside, por favor, wear your mask, because this is how we're gonna avoid getting sick. In any event, I wanna thank you and introduce myself. My name is Jose Hernandez Moreno. I'm a former NASA astronaut, and I'm a alumnus from UC Santa Barbara. Another fellow alumnus is Andrea Medina, who invited me to speak today to you native Skywatchers. And she asked me to share a little bit about myself, but you know, I think I have a story very familiar with a lot of us, in that I'm a first generation Mexican American, born here in California, but my parents are from Mexico, and we used to do the migrant farm working route, spending 9 months in California, 3 months in Michoacán, La Piedad, Michoacán to be exact. And I was fortunate that my parents, even though they only have a 3rd grade education, believe in education, and this is what allowed me to continue my education and become an engineer, become a scientist, and then become an astronaut. I was also lucky enough to be selected to fly in 2009 as the flight engineer for the STS-128 mission aboard Space Shuttle Discovery. And let me tell you, it was a 14-day mission to the International Space Station. It was the second to last mission to finish construction of the International Space Station. And we spent those 14 days floating, going around the world once every 90 minutes. Because, you know, once you get up into space, you keep traveling at the speed of 17,500 miles an hour, and you go once every 90 minutes. Now there's one big takeaway, or there's two big takeaways that I have in going to space. The first one was when I unbuckled myself and saw the world from a perspective. Less than 600 people have had the privilege of seeing the world from the outside. We were flying over North America. I saw Canada, Mexico, the US in between. And the beautiful thing that struck me is that you couldn't tell where Canada ended and the US began. You couldn't tell where the US ended and Mexico began. And that's when I realized, it hit me. I said, wow, borders are man-made or human-made concepts designed to separate us. And how sad, because from up here, we're just one. The other thing is, I told you that we went around the Earth once every 90 minutes. That means I saw a sunrise and a sunset every 90 minutes. And when I decided to watch a sunrise on one of these orbits, I saw the sun coming out from the Earth's horizon. And just as the sun pops out, the rays hit the Earth at an angle where you're able to see the thickness of our atmosphere. And let me tell you, I became an instant environmentalist, because what I saw was scary thin, the atmosphere. And to think that's the only thing that's keeping us alive. I think the environmentalists got it right, in the sense that we have to take care of our planet down here, because it's so delicately balanced. Anything we do is going to upset that balance, and it's going to affect the quality of our life. And if we want to leave this world in as good condition or better than when we found it for our grandkids, we need to leave no trace and conserve and be able to be good stewards of our planet. So I'm hoping that you enjoy this message, and always happy to talk to the native Skywatchers. So muchas gracias por todo. Les mando un fuerte abrazo. Take care. Muchas gracias. Adiós.
So there's so much that I love about Jose's message, and not the least of it is that he does like the Wakanda forever hugs, which is kind of cool. But there's so much that he does in that one message that is resonant with what you're going to be seeing in the rest of the show. We're going to be looking, as Annette says, at both sides, like trying to understand some of the physics and the astronomy and trying to understand the Mayan perspective of the sky in two different tracks. So I think the first thing to do now is to jump into our segment with our partners, and that is their explanation of the Chol Ki, facilitated by Andrea Medina and our Adelante Charter School partner of Andrea Carrillo.
The Chol Ki is the Quiche Maya word or phrase for 260-day count, which is an important part of the Maya calendar. It's also known as the Tzolkin, and in the center of Mexico, with Nahuatl cultures, it's known as the Tonalpowali. It's also known as the sacred round or the agricultural round, and it's an important structure to count time throughout Mesoamerica. To see how the Chol Ki works, we first learn that it's a combination of 13 numbers and 20 day signs. The Chol Ki day signs are Imish, Ik, Akbal, Kan, Chikchan, Kimi, Manik, Lamat, Muluk, Ok, Chuen, Eb, Ben, Ish, Men, Kib, Kaban, Etznab, Kawak, and Ahau. So you start counting with number 1, which is Hun in Maya, and then you go to number 2, which is Ka. So you go Hun, Ka, Osh, Kan, all the way to number 13. As you will place your number with a day sign. When you run out of numbers and you get to 13, you start again at 1, all the way until you finish the 260-day combination of 13 numbers and 20 day signs. And we have a wonderful team of first grade collaborators that will demonstrate that for you next.
Hun Imish, Ka Ik, Osh Akbal, Kan, Hochichan, Wak Kimi, Wak Manik, Washak Lamat, Bolon Buluk, Ok Ilahun, Buluk Chuen, Lakat Eb, Osh Rahun Ben, Hun Ish, Ka Min, Osh Kin, Kan Kaban, Wak Kawak, Wuk Ahau, Akshat Imish.
Finally. So where do we find these day signs? We find them in two different contexts. We find them in inscriptional record. These are carved hieroglyphic texts on monuments from the Classic period. And we also find them in books from the post-Classic period, like these screenfold manuscripts that we call a codex when we're talking about one of them, and codices when there's many of them. They're made out of bark paper, and they're applied a white finish to them so they can apply paint to them. We're now going to focus on one page of the Dresden Codex to look at a sequence of dates that present Chak, who is a rain deity and a personification of rain. You will see that there's a hieroglyphic text up at the top and a sequence of day signs here. This is what we call an almanac, because what it does is it repeats. It goes through the 260-day count in steps, and it repeats over and over again. So when you combine these together right here, your coefficient, the number 3, with these 3 dots, and here's the day sign Ish. So what you see is 3 Ish, and then you would make a progression all the way through and figure out what all of these day signs are. As we're looking at the Dresden Codex, it reminds me of the Mayan medicine women and medicine men that I get to work with in Yucatan. and the time that we got to create this very long list of all the medicinal plants that are used today, all of which are also recorded in historical documents, some of which share that a long time ago there were these books like the Dresden Codex that were written in glyphs, like the ones that we're looking at, that recorded information about the plants, about the medicinal practices, about all the knowledge that was used to be able to maintain one's health and to heal. And it's important to recognize how today there's still a very important relationship with astronomy, and how in order to prepare medicine, to harvest the plants, to harvest the medicine, to prepare it, to give it, it very much depends on the phases of the moon. And that's something that comes from all these records that we have today, as well as oral tradition, and is very much alive and strong today.
So one of the things that's really powerful about that segment, I think, is it pulls together so many of the themes that we're dealing with. For one, it demonstrates the complete honor that it is to be able to work with ancient Mayan cultures, because they left us the hieroglyphic writing system that gives us an insight that is it's unique. We have indigenous voices, expressed for indigenous audiences, and there's no interference of any other culture, any other effort to translate the materials that we see in some of the later documents. So with Maya hieroglyphic writing, we're really getting something that is brilliantly rich, but also very challenging to understand from the outside. But so on the one hand, we're exposed to the writing system, we're getting the basics of the calendar, and we're seeing this connection to health and healing and the notion of balance within communities. So much is coming out of that, just that one initial segment, Andrea. I really appreciate that.
Yeah, that was great, Andrea. I just want to add really briefly that we have in Dakota and Ojibwe, we're always talking about earth and sky, the above and the below. And the third important piece is it's a mirroring, and it's our participation. That is part of that flow. So in knowing the sky and the stars and knowing the earth and being a part of that rhythm, it affects us. We're a part of it. We almost like recalibrate ourselves to be a part of that resonance. We do have a quick question here from Brianna. Can you hear me okay? Okay. Hello, I'm a student in 6th grade. I'm sorry, but I forgot what language you were speaking besides Spanish and English. If I heard right, it was a language native to the Mayan people. Could you tell me what it's called?
Yes, so far the language that we've been sharing is Yucatec. There are many different Maya languages, and the one that we're sharing right now, because we're focusing on records and some of the content that we're sharing. Well, actually, Gerardo, you could correct me if I said anything that was incorrect. So we're sharing some Yucatec Maya language.
That's right. So the calendric system we generally use in its Yucatec form, but there are 40 some languages that are spoken that are all Mayan languages today. And what linguists, epigraphers have been able to do is work backwards to go from all of these languages that are living today to reconstruct the language in the hieroglyphic inscriptions, which is what we're going to be seeing shortly as well. So it's not the same. There's some similarities. There's some words that are identical, but there are changes over time. It's kind of like looking at Latin versus Italian or French or Spanish. And so you're going to have that kind of variation today. There was a more restricted language in ancient times that we'll be seeing. It's a great question. Thanks.
Great.
As we start to move away from the idea of time being something mechanical, let's think about lived Maya time with the story of Vukub Kakish that our 1st grade partners will share with us next.
Vukub Kayaks was a big red macaw living before humans lived on Earth. Sus ojos eran unos círculos grandes de plata que brillaban mucho. Sus dientes eran de oro, grandes y brillantes. Su cara era tan brillante que cuando subió al cielo le daba luz al mundo. When he came down from the sky, he closed his mouth, he closed his eyes, closed and his mouth, and the world grew very dark. At first, everyone was happy having a son. All the creatures of the world liked his life-giving light. The cool cookies sometimes will change his mind. He will get lazy, sleep in late. Todos querían saber si les daría luz para que pudieran ir a buscar comida. Pero nunca quiso hacer lo que él quería. A veces se quedaba en el cielo tanto tiempo que las plantas empezaban a secar, los animales empezaban a morir y hacía mucho calor. Todas las criaturas empezaron a enfermar durante esas épocas porque Vukukakish no se portaba bien. He was selfish. He did not care about others. He only cared about himself. As a son, Vukukakish wasn't a good son. So it was important that the hero twins did something about it.
This is the beginning of his defeat. Thus the twins said, "Good shall never come of this. People will never be able to live here on the face of the earth. We will try to shoot him with our blowguns. When he flies over his food, we will shoot him, thus causing him to be afflicted. Then his jade, his gold and silver, his jewels, his glittering things, and all things over which he keeps vigil, will come to an end. May it be done thus. For people cannot be created where only gold and silver are glory." "Then be it so," said the twins, and they shouldered blowguns. This, then, is the blowgun shooting of 7 macaw by the twins. This is 7 macaw in the great Nanshe tree. This, then, is the food of 7 macaw. Each day he would rise up to the top of the tree to knock down some of the fruit, and it is there that he was seen by Hunahpu and Shiblanque. The twins watched for him beneath the tree, hidden in its leaves. Eventually 7 macaw perched on the Nanshe tree to feed and was shot by them. Hunahpu aimed a pellet straight from his blowgun into his jaw. 7 macaw cried out, sailing over the top of the tree and landing on the ground. Quickly Hunahpu ran out to seize him, but instead 7 macaw tore off the arm of Hunahpu. He wrenched it back, bending it back at the shoulder until it was torn free from Hunahpu. Still, it was good what they did. The first episode did not result in their defeat by 7 macaw, even though he took away the arm of Hunahpu. So, then, 7 macaw went to his home, holding his jaw in his palms. "What have you got there?" said Chimalmat, the wife of 7 macaw. "What is it?" "2 rascals shot me. My jaw was dislocated by them, and now my teeth torment me with pain. This I have brought to hang over the fire. It will dangle over the fire until they come to take it back again. Truly they are rascals," said 7 macaw as he hung the arm of Hunahpu. Then Hunahpu and Shiblanque planned again. They went to speak to the first grandfather, whose hair was now truly white, also first grandmother, who was now truly humble. They were people who now walked bent over with age. Great White Pikari was the name of the grandfather, and Great White Koti was the name of the grandmother. The twins spoke to grandmother and grandfather. "We would like you to accompany us to retrieve our arm from 7 macaw. We will follow along behind you. You will say to him, 'Suffer these our grandchildren that accompany us. Their mother and father are dead. Thus they follow along there behind us. We provide for them by removing worms from teeth, which is our profession. Thus, Seven Macaw will see us merely as children, even while we are giving you our instructions, said the twins. Very well, they said. Thus they came to where Seven Macaw was seated on the edge of his throne. The grandmother and grandfather passed below the home of the Lord, while the twins played behind them.
Now Seven Macaw was crying out because of his teeth. When he saw the grandfather and grandmother journeying together, he asked them, "From where do you come, our grandfather?" he asked. "We are just making a living, thou Lord," they replied. "How do you make your living? Are not those your children that accompany you?" "They are not, thou Lord. These are our grandchildren. But surely we take pity on them and give them a portion. We give them our scrapes, thou Lord," said the grandmother and grandfather. The Lord was by then nearly finished off because of the pain in his teeth. Therefore it was with great effort that he spoke again. "I beg of you, take pity on me. What medicines would you make? With what medicines will you cure?" asked the Lord. "We merely remove worms from teeth, cure eye elements, and set bones, thou Lord," they replied. "Very well, cure then my teeth, for truly they ache constantly, and I can no longer bear it. I cannot sleep because of them, and the same goes for my eyes. Two rascals shot me with a blowgun, and since then I have not been able to eat because of it. Thus take pity on me, for my jaws and my teeth cause me anguish." "Very well, thou Lord, it is a worm that causes the pain. We will merely replace them. Thy teeth will have to come out." Seven Macaw replied skeptically, "It is perhaps not a good thing that my teeth come out, for it is only because of them that I am Lord. My teeth along with my eyes are my finery. We shall replace them then with these ground bones." But instead of ground bones, they were mere white grains of maize that were to be placed. "Very well then, take them out. Help me," Seven Macaw said desperately. So then the teeth of Seven Macaw were taken out. As a substitute, they were placed mere white grains of maize, mere shining white grains of maize. And immediately his face fell. No longer did he appear as a lord. At length all the brilliant blue-green jewels in his mouth were removed. Then the eyes of Seven Macaw were treated. The silver and the gold feathers around his eyes were plucked, thus completely removing the precious metal from him. He surely felt no pain, he just stared instead. Thus the wealth of Seven Macaw was lost, for the healers took it away. The jewels, the precious stones, and all that which had made him proud here upon the face of earth. It was truly the enchanted grandmother and the enchanted grandfather that did it. Then the twins retrieved their arms and implanted it back into its socket, making it whole again. They had desired the death of Seven Macaw, and they were able to do it, for they saw pride as evil and went to do things according to the word of Heart of Sky. Thank you.
Los gemelos héroes eventualmente se convirtieron en el sol y la luna.
I mean, those kids from Adelante Charter School, they're amazing. One of the reasons we wanted to go this route was to start off, yes, with the mechanics of the calendar, but also then recognize that time itself was not this linear mechanical thing. If you listen to the story, they're telling us that in their conceptualization, there's a role that the sun and the moon have to play in maintaining the health of the community. And so it's a reciprocal relationship between humanity and the cosmos that we live in. And so I think it's important for us as we move through and get into the details of like eclipses and of orbits that we're also keeping in mind that it's a different conceptualization of time that we're encountering here.
Yeah, Gerardo, just a really quick question. I was just wondering, do we know that the 7 Macaw is the Big Dipper, those same 7 stars? And the Scorpio at the bottom of the tree, is that the Scorpion constellation? Or is that kind of just a real controversial gray area? We don't know for sure if that's...
Yeah, this is the kind of thing where I could spend a little bit too much time trying to wade through. But Mayan astronomy is one of these things where people started seeing patterns before we could read the hieroglyphic texts. And so there were a lot of associations that were made and reconstructed, and they made a lot of sense, and it seems like it's compelling. But when you read the text now, which we can only do for the last 20 years, now we're recognizing that they were contextualizing these images in very different ways. And a lot of the interpretations that we find published, even as late as the 1980s, those interpretations have been overturned by our ability now to read the hieroglyphic script. So it's a really exciting time in Mayan archaeology, but it's also means that a lot of old theories are getting debunked.
Wow, really interesting. Okay, I'll let you keep going. We do have a couple questions for the next break, or the next in between.
Good.
Thanks.
Okay, so now we'll have a look at the classic Maya lunar series. This is Washaklahun Ubah Kawil. He was the 13th Kuhulahau of the city we now know as Copan. This is just a representation of the kind of monument that we have access to, and that provides a lot of the inscriptional record that we now pull from. Some of these inscriptions look like this. This actually doesn't come from this monument, but it is a typical inscription that includes the lunar series, and it will be the basis of what we start to explore in this section. If we translate it, then it looks a little bit complicated, but please don't worry, we're going to take it one step at a time. We won't go through all of it, but you will hopefully notice some parts based on the earlier segment. Here you have, for example, 260-day count date. This is the day sign with the cartouche around it. It's the day Ahau, and the number for the coefficient is 3, so we have the 3 Ahau here. Section up above that is the long count. The long count and then the 365-day count, those segments there, you can figure out how they work on our website if you're interested. The inscription ends, or this portion of the inscription ends with the verb stating what's happening on this day, Tadlam. It's telling us that it's the end of a half period. So we'll get into that now. What we're interested in is the part that we've grayed out. We return to that and we get to the segment that is what we refer to as the lunar series. Glyphs A through D and sometimes E. It's a little bit weird, a little bit funky, I know, but part of this happened for historical reasons. Archaeologists recognized that there was a regularity to these texts. They noticed that the regularity was more consistent at the end of the sequence, so they just started with glyph A here and they went backwards. Eventually they decided that this was important enough to give it its own letter designation, so they just called it glyph X and they threw it in there. So this sequence, A, B, X, C, D, sometimes E, is what we refer to as the lunar series. So if we kind of blow this up and then take it one piece at a time, then we start with glyph A, the glyph at the very bottom, and we find that it's really made up of 2 parts. On the left-hand side, we have a logogram here. This is just a symbol. So Mayan hieroglyphic writing is based on both sounds and symbols, and so they go together to write just about anything they could possibly want to write. In this case, we have a symbol for the number 20. And then on the right, we have one of these head variants. So it's a representation of the number 10, but it's just in personified form. And so together we have the number 30. Now, in all the inscriptions that we've seen, we find that this glyph A can either be a 20 plus a 10, or it can be a 20 plus a 9. So it has the value of 29 or 30. and they seem to alternate in patterns. Right? So glyph A, 29 or 30. Getting back to the theme of this overall show, we realize 29 and 30 is bounding the lunar synodic period. So it takes the moon 29.53 days to go from being new, where it's pretty much in line with the sun, to coming back around and completing one cycle. Okay, so 29, 30 days, first clue to early Mayanists that they were looking at something astronomical with this text. Right? Now, if we go to the next section, we get to glyphs X and B, and these help us understand the rest of the phrase now that we've deciphered them. We know glyph X to refer to a name. It's going to have one of a few different variants, and so for our purposes, we'll just refer to it as glyph X and not get into its translation. The next tells us that glyph X, Chol Ki, is the name of. And so when we put all of these together, we get the string, glyph X is the name of the 30 days. It's basically telling us that this lunar cycle of 30 days has a name, and the name is right here. We call it glyph X. All right, so now we can move on to the next part. We'll get all the way to glyph D. Here we have something that looks pretty familiar, a bar and 4 dots, so we can call that the number 9. On the right, the top, you have the logograph for the verb to arrive, hul. Below it, you have a phonetic complement, making sure that we know that this is the verb hul, and then telling us that it's in the past tense. Ya is a linguistic suffix telling us about verbal tense. So overall, we can read this glyph block now, just this one glyph block, as 9 days ago, it arrived. What arrived? Well, now we're looking at the next glyph. This is glyph C. In glyph C, you can pull a few things out right away. See the number 3. This here is a skull, so it's like this skull for 10, but in this case, it's referring to the actual deity, Kimi. And this is, it's wrote in this case, but it's much more prominent in other versions. We recognize it as the glyph for the moon, Below, you have the verb that controls it, kal, which means to enclose or to complete. And so overall, we have the enclosing of the 3 Kimi moon. What we're doing when we get to glyph C, though, is we find out that it's not as straightforward as one representation might tell you. It actually goes through a number of different variants. So that skull can be replaced by 2 different versions, which we call lunar patrons. So in the first case, we'll have Ishim, the maize god. And so this will be the 5th maize god moon enclosing. This will be the 6th jaguar god of the underworld moon enclosing. And here we have the 4 Kimi moon enclosing. And what happens is they go through sequence. You start off with the 1st maize god moon, and you run through 6 of those. Then you go to the 1st jaguar god of the underworld moon, and you run through 6 of those. And then you do 6 of the Kimi moons before you start the process all over again. And here you can just kind of see that this 3 Kimi moon would have been the period right before this 4 Kimi moon from different inscriptions. And what this does is it now gives us the overall period that they're working with. They've got lunar months, but they're embedding those within a larger cycle. And that larger cycle is 6 of these months, each averaged at 29.5 days, to give us an overall period of 177 days. And what that tells us is that in this text, when we look at the lunar series for this text, it's giving us that 9 days ago, the 3 Kimi moon was enclosed or was completed. Glyph X is the name of these 30 days. And it's basically telling us that this event that occurred in this historical time happened when the moon was past first quarter and was in its waxing gibbous phase. So that the scribes writing this would have seen that kind of moon when they were writing up this text. That gets us into the basic structure for how they were counting moons during the classic period. And we find then that we have both historical records, we have observational data, and then we have that nested within a framework that is to a degree arbitrary and changes from region to region, because each of them was making a different use of their observations based on their local needs. So one of the things that really does is it highlights the artistry of Mayan hieroglyphic writing, but also the personification within it. Again, we're seeing these symbols and often head variants, we call them, or full figure variants, where a number is represented by an entire personality. It's not just this abstract, Platonic ideal. It's actually got character to it. And so time, when it progresses, is more than just something mechanical. It's kind of a community all interacting. And that's what we're seeing in the attempt to capture dates and in the attempt to capture lunar cycles.
I find that fascinating, that a number could be a personality and a picture of what you call the head variant. That sounds very formal, but I mean, basically, I can't even imagine drawing a person's head to represent a number. Like, can you give me an example? Like, does it have like a meaning? Like the number 9 is a person that's a head that's really angry or something, or is it
No.
emotional?
So the number 9 is actually Yashbalam Ahau, and that's the jaguar god of the underworld we were just referring to. These deities, Yashbalam Ahau, is sometimes happy, sometimes sad, sometimes all kinds of different things, but has a personality. I think the best analogy is like thinking of, we often talk about, like at the very beginning, Chak as a rain deity, but we're really thinking of a personality to rain itself. And that makes sense when we compare like a hurricane, which comes through Mesoamerica often, versus the kind of the first rain of the season that's fertile in nature and that's bringing you life. And those two storms, they're both rain storms, but they have different personalities to them. And so when we're looking at nature, we can see different personalities and then we can personify them visually. I think we're seeing the same thing with time, that there are characters to time, and that's coming out in the hieroglyphs themselves. And it's not too odd for us. I mean, we think about Friday the 13th. That's got a meaning to us culturally, and that's different from Friday the 12th or Thursday the 13th. So these things have personality. It's just taking on a more visual relationship.
Well, in another perspective, like our indigenous teachings, like that we're related to all living things, rocks, stars, a blade of grass, anything with spirit. We were all created from that same source, that energy and spirit. And so like literally they are our relatives. So if it's a relative, it's a person, a kind of person, and it has that personality. So it does make sense, and I guess in that way. Do we have time for a question? What do you think?
Sure. Yeah, why not?
This is one of our Ojibwe elders. I don't know if he can talk, but if I'll try to see if he can talk. But Will, are you there? If he doesn't.
Okay, I'm here. Can you hear me now?
Oh, fantastic! Welcome,
Ani, welcome.
Ani.
Gracias to our wonderful people south of us. Your presentation is beautiful. My question specific to a connection on a more intercontinental level insofar as the Mayan and the location of some of the temples, specifically in Chichen Itza as an example, and some of the symbols, some of the beings, some of the creatures. I visited there and was excited because of some of the patterns that I saw within Ojibwe teachings specifically, and the Ojibwe up in the Great Lakes of northern North America. But my community, the reserve First Nation that I come from, there are pictographs nearby of a creature, a manitou, a spirit being called Mishapiju. And if we go directly south, we align parallel direct below to the Mayan land. So from where the Great Lakes are, directly south over the Gulf of Mexico into Mayan land, on the Yucatan, we make a connection there. But in between, there is also the Piazza, is another being along the Mississippi River that has a similar kind of shape of a serpent-like, dragon-like being. And the Mishabiju, Bijou is lynx, but as it connects to the stars, is that to the Ojibwe in our star constellations, the Big Dipper is Bijou. And so there was just some real strong associative connections to these supernatural beings, these creatures of mixed anatomy of creatures. So winged dragon, as an example, or winged like the feathered serpent, and the jaguar, and so forth. So I'm excited to hear your telling of these connections to both the stars and to the creatures and to the supernatural beings. So is there any connections that you can share that expand that knowledge or that awareness?
That's a fantastic question. Thank you so much for joining and for asking it. There's clearly what happens in Mesoamerica is that there is a transition. We have things that look like feathered serpents in the classic period and even earlier, so that's earlier than 900 AD. But then all of a sudden we get this Quetzalcoatl figure who's also Kukulkan, who's also Kukumats, and that is literally feathered serpent. And it starts to show up throughout Mesoamerica. Is very closely associated with the planet Venus. That's what you're seeing at Chichen Itza. That's what you see at Cacaxtla and at Xochicalco in the highlands. And so what we're finding is that that phenomenon overall in the post-classic for the Maya extends up northward. And you see connections to what's happening in the Southwest, the US Southwest, and then potentially moving all the way over to the Mississippi region. And that might very well be the connection that goes north. So one of the things that it's really hard to track, but we know folks were exchanging knowledge, they were exchanging goods, they were exchanging customs and foods. So there's no reason why they wouldn't be exchanging ideas at the same time. That's not to say they're going to be identical, because you can imagine if you can't just text somebody an idea, it's not going to get there immediately. Ideas will transform as they go from one space to the next, and they have to be meaningful to that environment. So I'm sure you could very easily find connections. It'd be really fun to explore them further, I think.
Absolutely. Thank you for that. Andrea, do you have anything you want to add? I would love to hear.
Hi, I'd say Gerardo's the expert in archaeoastronomy. But there's definitely lots of connections that I'm thinking in my head, not only with the Maya culture, but with all Mesoamerican cultures and even cultures in northern Mexico. I was just in the Comcac Nation in Sonora, Mexico, and they're phenomenal astronomers, and their entire life is based on astronomy and their lunar calendar. And there is a deity that comes from the Milky Way that explains how their fishing and their hunting calendars should be based, and it's still very much followed today. And I'm just coming out of that today. And so I was making the connection with the question that you were asking. And I'm also from Yucatan. I was born and raised in a Maya community, and everything is aligned, like Annette shared at the beginning of the webinar as well. You know, what's happening above is happening below. And so our agricultural system, our healing system, everything is based on or related to the cosmos. And there's much to share, but I'd be happy to connect with you after the webinar as well.
That is absolutely. I think we have something in the works here that goes beyond this webinar for sure. So more work ahead. Yeah. So let's get to work.
Yeah, miigwech will. And I mean, if you think about it, feather serpent, that's the feathers from the sky above, the serpent from below. That's the embodiment of this fundamental teaching above and below. And that's in all of our indigenous teachings. So I definitely think there's a lot more there. Okay, back to the show. Gerardo.
Let me see if I remember where we were. Okay, our next segment is on Schultun, a classic Maya city of Schultun, and modern satellites. So it turns out that one of the more interesting recent developments in Mayan archaeology came about through advances in satellite technology and their applications. So what we're going to do here is we're going to run through, explore a little bit of what makes satellites work and how they're connected to Mayan astronomy today. And it starts off with a pretty simple question. And if you look into this, you'll find there's all kinds of satellites orbiting our Earth right now, but the fundamental question is, how is it that they get up there? And yes, the answer is that it's complicated. But what's nice about it is that the physics, the underlying physics at the basic level is pretty straightforward. And if you go to any, intro to physics textbook, you'll see this is how you start to derive it, projectile motion. See a vector and an angle. But we really don't want to take that approach. Instead, let's do something a little more fun. Same idea, but let's look at soccer. Projectile motion is just ball getting kicked at some angle relative to the ground. Happens all the time. Once it's in flight, though, that ball is subject to two different forces. On the one hand, it's gravity. It's going to fall back down to the ground at some point. And as it's flying through the air, it's going to meet some wind resistance. Now, that makes things interesting, both when you think about satellite technology and what we're going to do there, but also when we think about soccer. Turns out that those forces are pretty useful. If you've ever watched soccer, I'm sure you've seen attempts at, if not the successful bending of a soccer ball. What happens then is that the ball actually curves while it's in motion. That turns out to be possible because of wind resistance. Take a short digression here, just explore the fact that you can take this isolated system, look at the ball, and watch as the air flows across it, and it turns out to be a really nice relationship that allows for this bending of the soccer ball. If we put this ball in motion, if we give it a spin, then we find that what's happening with the wind airflow around it is that on one edge of the ball, on one side, the airflow of the wind is in line with the spinning of the ball. And so it flows in a certain kind of manner when they're both in the same direction. The opposite side of the ball, though, the direction of the ball is spinning against the wind that it encounters. And so now you're going to get a different kind of effect on that side. What these do together is these two opposing forces create what's called the Magnus Force. And the Magnus Force will actually push the ball in a given direction. If we take our image and we flip it around a little bit, we'll see that it lines up with what you can see on Wikipedia. And this is just a little GIF representation of airflow. You can see all of the, you can see this is the fluid traveling in this direction. This bar starts to spin, and as it spins, you notice that there is a rippling effect back here. That's showing you the difference between the airflow over this side and the airflow over this side, which generates the red line representing a force. There's a force on this bar resulting from the spin through an airflow. When we get back to our soccer ball, what it means is that you kick the ball off center, you create a spin to the ball, and as it flies through the air, the wind resistance generates the Magnus Force, which bends the ball, hopefully, into the goal. Right? So in soccer, it turns out that wind resistance is good because you can start to do some fun things when you kick the ball. When you get to satellite technology, however, it's not so useful. What we do in order to get to this next step, in order to understand how we're going from just projectile motion to satellites, we think about what it takes to get something into an orbit. And it means that we have to go back and think about what are the forces controlling the ball's motion or the satellite's motion relative to the Earth. And the simple part of it is just the first few steps, which is that you realize that the force that you apply to the ball on impact is going to affect the velocity of the ball, and the velocity determines how far it's actually going to go. On our Earth, the way everything is laid out on a soccer field, that just means the ball is going to go farther down the field. If we were to imagine, however, that this young woman were playing on a spherical soccer field, then what we'd see is that kicking the ball is going to have an interesting effect. If there's still gravity on this planet, this tiny little soccer field planet, then yes, kicking it with a certain smaller force is going to give it a smaller initial velocity, and it'll fall down to the surface of the planet. kicking it a little harder gets it going a little bit further, until you get to a point at which you can kick the ball so hard that it's continually falling, but it's falling at the same pace as it is attempting to escape with the velocity that it's given. And what that does is it ends up putting the ball in circular motion or in orbit around your miniature planet. And that's a metaphor for what we're actually doing with satellites, right? We need to get them up at a speed and at a height that they can be continually falling, but remain at an altitude above the surface of the Earth. And that's why rocket ship technology is so complicated, because you need to get this thing past the wind resistance, out of the local force of gravity, to a point at which it can maintain this motion. And so it is complicated, but we now have the technology and the engineering skills to be able to get these things up, not only in orbit, but also on much more elaborate missions, which is what we're going to be seeing in this next segment on the Artemis mission.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
Kind of makes you wish you had access to that kind of like music background technology and putting videos together.
Oh yeah, they did a good job. So I'll put the link. This is a YouTube video anyone can access. It's called How We Go. I'll put the link on the chat or on the Q&A. But we did have a quick question here. Someone was asking about how the Maya Astronomy connects to the national science standards. And, you know, I think this segment really started to touch on that, like with the projectile motion. Would you like to say anything else about that connection? That is our two-eyed seeing piece there as well.
So one of the things that I've always found really fun is to try to take the things that you can go out and experience and then connect them to the much more abstract and elaborate kinds of activities that happen in sponsored science. And so this is something we've done before. We've gone out and had kids kick soccer balls, and you can do things like take slow motion video of them, and you can measure trajectories and angles, and you can do some really, in the end, it's some very straightforward mathematical modeling and some calculations, even as simple as making tables and calculating averages by playing soccer, but then looking for ways to tie that to projectile motion, and then projectile motion to the kind of science that's going on in our Artemis mission and mission to Mars. So I think part of it is just finding those connections that allow you to bring the everyday to the much more laboratory confined activities.
A really great connection is coming right up in the next section with the discovery of using the infrared radiation to see below the jungle canopy. So maybe we should just go right to that. But there's a lot we can say here about these science connections too.
3. So yeah, you can definitely do a lot with rockets once you get that technology, once you understand orbits and can engineer appropriately. Now we're going to bring it back down to Earth, talk about Schultun and how it relates to modern satellites, and how this all brings us back to the exploration of Mayan moons. Okay, so now depending on where the satellite is in orbit, it's going to have a different purpose. In some cases, you may want a geostationary orbit, in which case you're going to have the satellite sitting above a very specific spot over Earth, and it's not really going to vary location. Other times you might want it to roam, so it'll take a path or trajectory around the entire Earth. What we're looking at are the kinds of satellites that are used for taking images, taking photographs, but also putting specific lenses on them to take infrared imagery of the surface of the Earth, which gets us through things like clouds and weather, and doing so in a way that reveals features of the surface itself. That takes us back to our archaeology story, which comes along by way of the archaeologist Bill Saturno. He and I went to graduate school together, so I remember a lot of the story, not just from the articles and the YouTube videos that you can look up, but also just from hearing it from the horse's mouth, so they say. And it turns out that what he's doing is he was looking to go back to some monuments that had been recovered. We knew that they were there, but they hadn't been explored in some time. They hadn't even been located in some time. So he was going to go back to this region around Washington to look for some monuments, to take modern photographs of them and make illustrations of them, to bring them into the archaeological record. It was supposed to be a pretty short trip. He was going to go out for a couple of hours, get to the site, take some photographs, and then return same day. But instead, he ended up getting lost. He won't always admit that he got lost, but he pretty much got lost. And here's a representation of some of this rainforest, not too far from the location that he was at. This is in Belize, and this is a graduate student that I currently work with, Tony Gonzalez. But you can get a sense just from this photograph of how easy it would be to get lost if you didn't have a well-used path to follow. And so in any case, Bill gets lost, has to spend the night out in the rainforest, camping, running out of water. Next day decides, well, we shouldn't be too far, so let's press on and see if we can find the site and still make it back in time for lunch, but doesn't go so well. He ends up kind of stuck, kind of frustrated, and in need of water. His companions go off claiming they're going to bring water back. He looks for some shelter from the hot sun. He does see an old looter's trench in a mound that could provide some relief from the sun. So he kind of goes in there and has a seat. He looks up, and what he finds is one of the most brilliant murals of the entire Maya region. It comes from the pre-classic. Eventually they clean it all up and they make a new illustration of it. Heather Hurst does a painting of that mural, and we see that it's recording mythology from ancient Maya times. And the reason he found that is because the mound that he was crawling into in this little overhang was at the base of this huge structure, and he was walking into this room that had the murals painted around it. This was the site of San Bartolo. So eventually they get water, they find their way back. He makes it back to the United States and says, hey, there's got to be these other sites that are around there in this area, and there must be some other technology we could use to find them. So what are our options? Well, luckily, he comes across a guy, Tom Seaver, who's working at NASA, who's also an archaeologist, who's been looking at using infrared technology to detect archaeological sites. And what they find together is that there's this really nice relationship between the colors of the floral canopy when you're using infrared technology and the soil content that the trees are rooted within. So because the Maya built their architecture with limestone, that changed the soil that the trees were growing out of, and that chemical composition was reflected in the foliage of the trees themselves, so that when you're taking infrared images of them, you can see them color-coded. You can find those trees that are growing on top of mounds that are rich in limestone contents, or they're rich in building material. And then you can go back and you can check to see if, in fact, there's an archaeological site underneath those regions. And when he did that, that led him eventually back to the site of Schultun. Schultun is a classic Maya site, and within Schultun we'll find more on the development of lunar technology and lunar recording within classic Maya hieroglyphic writing. This is the mound at Schultun that we'll be exploring next. Okay, I'm seeing some interesting questions, but I know that we're also pretty close to overtime. I wanted to comment on one thing. There's a question of an archaeologist working at NASA, and yeah, if you have a chance, just Google Tom Seaver. It's S-E-V-E-R. He's really got an interesting story in terms of how he was interested in archaeology, got interested in remote sensing technology, which is what we're dealing with, remote sensing, and was working for NASA on exploring the utility of it. So, okay, so that leads us to the moons or the lunar record at Schultun. So a quick reminder that Schultun is here in the eastern portion of the Peten heartland, part of the classic period fluorescence of the Maya civilization. Here's that mound at Schultun that the trees would have been kind of growing out of and capturing the limestone in the soil to kind of give a clue to Bill that there was something here to have a look at through that satellite infrared technology. This is the representation of the interior of one of these rooms at Schultun that had yet another mural in it. It's not the same mural from San Bartolo. Bill somehow found his way into recovering two different separate murals. This one, though, is specifically about the moon and about lunar records, as opposed to San Bartolo, which was the formative period mural on mythology. Here at Schultun, we encounter part of the called the elite class, the nobility, but those who were not the kuhulahaus, they were working for the government in a sense as astronomers. It's not just at Schultun that they show up. We have records of others. There's some who are a little kind of well known at the site of Palenque. Here's a figure here who's identified by his name, Chakchan. He's an Akuhun, which is a title given to these learned members of society. Those guys in that figure are from the side of Palenque, which is way on the other side of the Peten from Schultun. And so we're going to kind of jump over to Palenque before we return to Schultun for the record there. One of the reasons we do that is because we want to get another sense of how astronomy played a role in classic Maya life, classic Maya thought and culture. And so kind of one of the most famous images from classic Maya times is this one here. It's got all kinds of unorthodox interpretations. We're going to go with the straightforward one here, what we can tell from the texts and from the iconography itself. We know that this is the image on a sarcophagus lid, the lid for Hanapakal, who is the kuhulahau of Pakal, or the site we now know as Palenque. Here you have the carving and then a nice line drawing of it so that we can get a look at some of the detail that is harder to see unless you're there in person looking at the lid. If we pull it over, we can see that on the outside, so here's the figures we were just talking about, the akuhuns. Around the outside, though, they are connected within what we call a sky band. So these little boxes all in a row, they wrap on both sides. That's the sky band, and within it there are elements that speak to the celestial realm. Here, for example, you have the glyph Ek, which stands for star or celestial body. This is a cross band symbol, which is kind of a generic symbol saying this is stellar, this is something in the sky. Below that, you have a glyph for the moon, we've seen that in other places already. Here's just the logograph for Chan, or the sky. On the other side, you see some more crossed bands, another Chan glyph, and then here, Akab, the glyph for darkness. And so here, overall, this is telling us that this is a celestial band. What's inside is actually not unique in Mesoamerica. It's part of a conceptualization that resonated across regions. So here we have a representation of Hanapakal, and here he's coming out of the underworld. These are these serpent jaws that symbolize the underworld, the area under the surface of the earth. Out of him grows this jade tree, and then there's this bird creature on top of that tree. That resonates with a codex image, a manuscript from central Mexico in the Mixtec region, known as the Codex Borgia. And if we blow up this image down here, we see the same structure. There's a reclining figure. Out of that reclining figure is, in this case, it's a cactus, a very large cactus, kind of like the jade tree, and then an eagle sitting on top of that cactus, like the celestial bird. And what these two images are really speaking to is the nature of the role of the Kuhulahau in society. And that is that the Kuhulahau wasn't a ruler in the sense of getting to dictate and say whatever he or she wanted to, and that was law. Rather, the Kuhulahau sat in the middle of a great balance, a balance that recognized different communities that humans interact with. They interact with the celestial community, that community that exists in the realm above the floral canopy, so above the highest ceiba trees. All of those entities, it could be birds, it could be the clouds, it could be the stars themselves, all of them, they live within the celestial realm as a community. Our community, which is familiar to us on a daily basis, is that region between the floral canopy and the surface of the earth. And then the underworld community is all of those creatures that do live beneath the soil. It can be things like worms or snakes or rabbits who go into their burrows. It could be bats in caves. It can also be diseases that live within those caves that are dangerous for people to go in and explore. And they come back and they get sick because those diseases live underground in the underworld community. The key is, though, to recognize that it's not that they're just physical realms. They are communities of entities interacting with each other. And that then brings us back to the very beginning of our story, in which we recognize that time too is a community. And so in a Mayan conceptualization, time becomes a community that helps us understand and relate to the other three regions and the communities that live therein, and develop a balance between our human community and the communities that we share this cosmos with. And so we see really the charge given to these figures at Schultun, the figures at Palenque, the figures really across the Maya region who were engaged in understanding the celestial realm so that they could know both time and how time relates to the patterns that they see around them. And so that allows us to then contextualize what we see at Schultun, which isn't just really nice images of people, of figures, of Kuhulahau and of Akuhuntak, but also of numbers. And so one of the things that Bill found when he went to Schultun and he looked at one of these walls, it wasn't just images of people, it was images of numbers and of calculations. Turns out this is one small hunk of a huge sequence that I've represented here. It's a whole bunch of numbers in Mayan positional notation. We're not going to try and break down the whole thing all at once. Again, we're going to take it a step at a time, recognizing that these can be represented as Arabic numbers. And so we could translate this as the number 8, bar and 3 dots. This as 3 bars and 2 dots, or the number 17 in positional notation, so that these have the value of 360, these a value of 20, and these a value of 1 each. And if we just strip away the rest and look at the first 7 columns, it becomes a little more manageable to deal with. We see the number 817, 1714, 1811, which can then be translated into 177, 354, 531 using our decimal notation. And then these, we find, contain a pattern. That pattern is that they're multiples of 177. 1 times 177, 2, 3, 4, 5, 6, and almost 7. It turns out that 1240 is not quite 7 times 177. 1240 is 7 times 177 plus 1. And so this is where we get to see a little bit of how these Mayan astronomers at Schultun were working with larger lunar periods, larger than just 1 month at a time. So to get there, we ask really 2 questions: why 177, and why 7 times 177 plus 1? The first part, 177, we've already seen this. So when we look at the way classic Maya astronomers calculated moons, they looked at these 3 periods of 6 moons each for a total of 177 days. So what they're doing is they're tracking these larger collections of moons. And then what they're doing is they're accommodating for the fact that 29.5 is not close enough to the synodic period of the moon to be able to keep track of it over long periods of time. Instead, you have to make a small adjustment. Just as we make adjustments to our solar year and add a leap day every 4 years, they wanted to compensate within their calculations of the moon to be able to track new moon over long periods of time. So what they did is they took 6 groups of these very standard 29.5 day approximations, and then they added to it 1 group of 2 moons at 29 days and 4 moons at 30 days. So they stole one of these months and they added an extra day to it, which gives us that overall 1240 interval. It tells us then that they were taking 42 moons total, and they were counting them as 1,240 days, which gives them an approximation to the actual synodic period. It gives them the approximation 29.52, which is getting closer to the number that we know today and that we use as 29.5306. That's only part of the way though, and that's because this is only part of the overall text. If we go through and look at the entire sequence, we find that it ends with a total sum of 1354, which is 4,784 days, and it's counting 162 moons. So that gives them, in the end, a final approximation of 29.5309 days, which is incredibly close to the number that we use today. So you can see that they were able to project backwards and forwards in time and capture observational data for the moon itself. What were they doing with this? Gets us back to the same old story. Here's a representation again from Palenque of Kan Balam, the Kuhulahau there. He was actually the son of Hanapakal, who we saw on the sarcophagus lid. And we'll take a look at this in a second, but for right now, we want to focus in on just the beginning, which is that inscription that should look a little familiar to us now. We know it's a date. We know it's starting with this ISIG. It's telling us, hey, look out, there's a date coming. The dates here are really nice because the components of the calendar are using the head variants again. So they're personifying time for us, reminding us that this is a community of figures. It's not just a mechanical time. And then we get a lunar series. What's nice is that this lunar series is related to a date that occurred in mythological times. So Kan Balam's scribes were actually going back 3,000 years in the past and trying to figure out what the moon looked like on those dates when mythological events were occurring. And in order to do that, they used the same approximation of 29.5309 days, which is why we call it the Palenque moon formula, because it first appears most early in the archaeological record at Palenque with these figures. And so then if we're looking at what this actually represents, we're seeing that it's giving Kan Balam a representation as continuing the practices of those figures who were maintaining balances between communities in primordial times. And you can see a lot of that imagery is speaking to this notion of the rule of the Kuhulahau in society and relative to the environment. Here's a kind of a structure, a representation of a mountain. Out of the mountain grows a personified corn stalk, and in the place of corn ears, there's human faces. And at the top of this corn tree-like structure is this celestial bird representing the celestial realm. So that overall, again, we're talking about the role of the Kuhulahau in maintaining the balance between communities, between regions in the Maya world. So what this tells us then is that these astronomers from Schultun and from Palenque were really engaged in using astronomy as a means of understanding time, because they're understanding the communities that they're interacting with and how they can help them better understand how to maintain balance between humans and the environments that they live within. It also helps us see that there is a very large community of scholars all working together across the entire region. And it's nice that these both come from Palenque and Schultun, really at opposite sides of the Maya region, telling us that they're all communicating and they're all working on this together, if not always politically aligned. That very last point reminds me of a question that I saw earlier in the Q&A about regional differences. And there's some fascinating stuff there that, yes, there's variation in hieroglyphic writing from city to city, but also in how they tracked that one portion of the moon that was arbitrary, that wasn't connected to the moon age. And so you can sometimes see political patterns coming out of their astronomical records, and how it's really kind of, it's our imposition of these categories onto the activities of human life. It's not something that they necessarily would have subscribed to.
Great. And Michelle asked about the static linear nature of calendar time in schools. What can you all imagine calendar time could look like in schools? What should it look like? Do you have a quick answer?
I've seen some really fun exercises where what you basically do is you take your local environment and you start talking to your class about what changes you see over time, and you start to track them. And you can basically make your own local version of a seasonal calendar, which is going to look very different from one region to another, but can help you kind of get a sense of different scales of time within a classroom setting. I remember our colleague, Valmir from Brazil, who did that in the Amazon. I don't know if you remember him, Annette. So we've done a lot of work to get here, but now we can finally look at eclipses in the post-classic. To do this, we'll turn to the Dresden Codex. It's an indigenous manuscript painted probably in the 14th century, perhaps a little earlier. It's made up of 72 pages, all painted by hand, with hieroglyphs, with images, with numbers, and with dates. It's broken up into a whole bunch of different chapters, and each chapter deals with a different phenomenon, a different cycle. So we refer to these as almanacs when they're not tied to historical dates, and tables when they're anchored to a date and then they run through periods of time. We find both Yucatec Mayan influence in the writing of the script, so that helps secure that it was probably in the post-classic and in the northern part of the Yucatan Peninsula. And then we recognize that the imagery throughout it draws from the international style that became a little more fashionable for artistic work in the post-classic. In terms of where it came from, again, the northern portion of the Yucatan Peninsula, most likely this is a version that was copied and preserved at the city of Mayapan, which is one of the latest post-classic cities in the Maya region. See it up here, not too far from Chichen Itza, and it does have the architecture which resembles the architecture of Chichen Itza, though it's much smaller. In any case, we get to the text and we jump right in now because we're comfortable with a lot of our iconography and our writing system, and we can jump into the middle of the eclipse table. We'll see on page 55, for example, some clues that we're looking at eclipse information. If we kind of hide most of the stuff and focus just on the images, we should see something a little bit familiar at this point. I'll draw your attention to the sky band at the top, with here inside the far left box, you see a moon glyph, kind of a sideways Chan glyph on the far right. We're seeing something connected to the sky, to the celestial realm. Then if we look here, we can see there's a little face on the inside. in his forehead, which is where Maya rulers, deities kind of marked their identity. We see the symbol of a sun, so kin right here in the forehead. And if we kind of extend this, we think this this appeals to the glyph for Chen or for caves. So to a degree, you might be able to extend this to interpret sun in a cave, or sun being covered up, sun in hiding. So there may be a metaphor here connecting us to eclipses just from the imagery itself. When we look through the rest of this table, we find that it's most certainly referring to something eclipse related. So jump right into the numbers now, and this should be familiar to us. The 8 in the 20s position and the 17 in the units, and that gives us the interval of 8 of 177. And you see a whole string of them across the bottom of the page. If you want to cheat, you can also see down at the bottom of the next section, there's a whole string of these as well. In the middle of our page, we have the 260-day count dates. These are in strings that are sequential, so 2 muluk, 3 ok, 4 chuen, and then each of these, if you were to add 177, would take you to its partner to the right. So 10 kimi, 11 manik, 12 lamat, and then you can go through and see how that works all the way through the rest. What we're seeing is we're recording a procession through time, separated by intervals of 177 days, and they're giving some little wiggle room that it might not be exactly this day, for example, 3 ok. It could be a little earlier or a little later. And then the hieroglyphic text, on the one hand, these are intervals that are just summing. It's a running tally of these intervals down here. So these can get pretty big pretty quickly. We have numbers in the thousands up here. Hieroglyphic text we'll talk about at the end. So let's review a little bit about eclipses just to make sure that we're seeing the phenomenon behind the numbers. And for this, we go to NASA's nice little short video on eclipses.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow. But the moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. Although the Earth and the moon always cast long shadows, they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow. Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
So now understanding that eclipse motion helps us see why they've recorded the intervals they have in the Dresden Codex itself. And when we get to this page, when we get to the multiple pages, we find that they're capturing it numerically. They're looking for patterns of observation that allow them to potentially make predictions. And what we'll find is that when we go throughout these 6 pages of the eclipse table, we'll find strings of 177-day intervals capped by or ended by these strings of 148 days. You can see here the 7 and the 8, giving us 148 at the end before the next eclipse image like this one. So strings of 177 and then 148. Not always the same number of intervals, but that's the pattern that we find in the Dresden Codex. Now, when Anthony Aveni, who's an archaeoastronomer, took a look at this pattern way back in the 1970s and 80s, he realized that he was looking at eclipse phenomena that could be modeled. So what he did in Skywatchers of Ancient Mexico, which is it's a canonical text, anybody interested in Mayan astronomy should have a look at this. It's there's a new version, 2001, check it out. But what he did is he went back to the 5th century and he said, let's look at all the eclipses from this time period. And charted through, broke them up into intervals of 177 days, potentially 178. I'm not going to ask you to process this entire table. What I'll do is highlight a pattern, which is that at the end of these strings of 177 or occasionally 178 days, you have the 148-day interval before an eclipse. And that shows up multiple times throughout this single century. So if you're astronomers and you're keeping records and you're doing it over, even 20, 30 years, you're going to find a number of examples of this phenomena, and it's going to help you build your table, especially if it's already based on an understanding of eclipse periods of 177 days, which we saw from the classic period. And what they're doing now is they're pulling these all together into an attempt to capture eclipse phenomena on long-term bases. If we go back to page 52, we see yet another example of how they're trying to capture this information. And that comes out of this one portion of the right-hand side of page 52, which we'll pull out and translate. Again, don't worry about the long count dates, and just unless you've gone ahead and learned how to work with them. We can do this math just by using our knowledge of the 260-day count. We'll find that these days are separated by 15 days. 12 Lamat plus 15 days gives you 1 Akbal. And then 1 Akbal plus 15 days gives you 3 Etznab. And if you're wondering, well, okay, why 15 days? What are these intervals telling us? We go back to our eclipse phenomena and we realize that, okay, if we were part of the cycle of the moon revolving around the Earth and the Earth in its orbit around the sun, if we have a lunar eclipse visible, it's possible that 15 days later, we'll have a solar eclipse. And then 15 days after that, it is still possible. There are events, even in the not too recent past, in which you can have 3 eclipses, lunar, solar, and lunar, all in the same month, all separated by these intervals of 15 days. So it may very well be that what we have here in the Dresden Codex is an actual historical record of that occurring. On the other hand, no one has yet figured out how to place all of these eclipse events that we have recorded in the Dresden Codex with historical phenomena. There's still an open question. Was this a work in progress? Was this the beginning of a collection of dates? Were they cycling it? How was it actually used during its time of historical significance? Right now, that's still an open question. And so any of you watching, are free to start exploring that mystery. That is a genuine mystery still. Now, what were they doing with this information? Shouldn't be surprising at this point. When we look to the text, we find that they're referring to this term umuk, which is the sign of, or it can be translated as the omen of. What they're doing with this information as they're reading eclipses, as they're reading cycles of the celestial realm, is they're looking for signs that help them understand the role of human community relative to the cosmos. And what this looks like, it's information for the government so that they can develop a leadership as health maintenance. You're reading the symptoms of your existence in this context, and then you don't just respond mechanically. There has to be a concerted response. It's multiple, both in terms of the symptoms you're reading and the responses that you have to bring in order to engage that balance, that healthy position within your environment and within the cosmos. So in the end, we're seeing this notion of community, this notion of humanity's place within the cosmos. It is a very organic one. It's a very personified existence of the humans relative to the environment and the cosmos. And that runs throughout Mayan art, culture, and philosophy. So I think we made it. I feel like one of the things that's important about the very end is just the connection that it brings us, that takes us back to the beginning. Andrea's work with curanderos and the role of healers in modern times and their role in society relative to ancient astronomers and their role in their ancient communities. And it all kinds of fits together in the approach to the role of humans in the cosmos, which is distinctly indigenous, I think.
Yeah, that's a great lead-in for this question that we had earlier for Andrea. What is the connection between Mayan acupuncture and Chinese medicine, where classic Chinese medicine is based in astronomy? This is a question for Andrea. What would you say to that?
Gracias. Aprovechando que tenemos interpretación, responderé en español. Definitivamente hay una relación entre la manera de comprender el cuerpo humano y sus diferentes partes y la manera de mantener un equilibrio entre el cuerpo físico, el cuerpo anímico, el cuerpo espiritual. Esas son áreas donde hay similitudes entre la medicina china y la medicina maya. También hay algunas terapias que podrían parecerse a la acupuntura, donde se utilizan espinas para liberar ciertas enfermedades o presiones que tiene el cuerpo o enfermedades que tenemos atrapadas en la sangre o en el cuerpo. Pero no es una especialidad mía. Hay estudios de un profesor, Javier Irose López, lo escribiré en el chat, que tiene publicaciones sobre esta relación entre la medicina china y la medicina maya.
Does anyone want to give a quick summary in English for anyone that wasn't up to speed on their Spanish? This is a real quick summary, or?
This was interpreted in English as I was sharing in Spanish.
Oh, we didn't hear it on this side.
Maybe not as panelists, but on the interpretation link.
Oh, okay. I got the gist.
Thanks.
We are really using up all of our time, but we do have some more questions, and I'd like to take this question from our colleague, Steve. Steve, are you on the line? You could talk and ask your question. Steve Goldberg.
No, I don't have any questions in it.
Oh, okay.
I really enjoyed the presentation, so it's been fantastic tonight.
Oh, okay. Well, thanks for the thumbs up. I saw your hand was raised, so I thought I would get your, maybe you had a pressing.
I must have done that accidentally.
Okay, well, thanks for listening. And thanks for your...
Andrea and Gerado, both you've been excellent. Thank you very much.
Thank you.
Okay.
Thanks so much for listening.
Thanks, Steve.
Thank you.
Gerardo, I was going to ask you real quick. Do you honestly think there are a lot more murals that are hidden under the forest canopy? And when can we go and look for them? Where do we sign up?
I think it's a struggle, right? Because on the one hand, yes, there's a ton of stuff still to be explored.
Really?
But there's already so much that we have that has been excavated. So much that sits in repositories and museums. There's so many inscriptions that still need to be understood, that there's plenty to do. Excuse me, plenty to do without having to dig more at this point.
Okay, so how about another question from the Q&A? This is one from Katie. Are there any myths about indigenous cultures of this time and their understandings that you can debunk for us? This is from Katie.
There's that could be, I mean, just
a whole other 2 hours. Oh, weeks.
do something off the internet and it's probably debunkable. Again, it's really a challenge because there was so much, it's an ethical issue, right? There was so much interest early on in kind of going to the rich pyramid structures and excavating them and pulling out whatever you can, and then exoticizing Mayan people, turning them into something other than a historical group of people. And so a lot of interpretations came into the scholarly literature and the popular literature through most of the 20th century. And it's only now that we can read the texts and we can say that, oh, this is what they were saying about themselves, that we can check a lot of that interpretation that came along when we were really imposing what we thought we understood them to be from our own biases and not from what they were telling us they really are. So I'd say stay tuned. Keep track of the scholarship that's coming out, because since the text was deciphered and there was a circuitous decipherment in the late 90s and early 2000s, that's the material that's really it's really strong. The stuff beforehand is a little more speculative.
One of the questions here from Bo says, do we know if the Mayans predicted major planetary conjunctions or other events? And I can't help but mention that the big conjunction is coming up in 4 days on the winter solstice. As everyone probably knows, Jupiter and Saturn are going to be looking like one bright star, and hasn't been that close. And at first I heard 400 years. Now I heard later at a seminar, it was like really 800 years. They haven't been this close. So this is actually happening on our solstice, the first day of winter. So have you heard of other Mayan teachings or seen that in the almanacs or tables where there was, like with the lunar eclipse, but it would be keeping track of or having a special marking of planetary conjunctions like that?
Yeah, so there's a whole, actually I wrote a book on this. It's what we refer to as contrived numbers and astronumerology. And there was an invention of it's called the 819-day count. And the 819-day count, it was a numerological tool where you could basically, what you did is you converted planetary periods into their canonical version. So what they were doing with the moon was they were saying it's either 29 or 30. They didn't use fractions to say 29.5. So what they did with Venus, and we see this in the Dresden Codex, is they used 584 days, and then they had long-term corrections to make it 583.92. They did something similar with the 819-day count, where they were looking at Jupiter and Saturn as 399 and 378 in their canonical periods. And then they put them all together in this construct so they could calculate what their relative positions would be in the deep past, like on that text that I showed with the mythological lunar record in it. And so they're referred to as like contrived numbers, but is basically tracking planetary periods over time. The really fun thing about Saturn and Jupiter, and you can really see it these days if you go out and you look at the evening sky. Today they were right next to the moon, and it was beautiful. And what happens is their periods are so close together that it looks like they're traveling together for a long time. And in the iconography from classic Maya times, we see them represented as paddler personalities. So they're both in the canoe, because what they're basically doing is crossing the sky in a canoe together night after night after night. And they're referred to as the paddler gods because of that.
That's cool.
Pretty fun.
Okay, so what do you think? We're getting kind of late in the time. Do you want to take one more question or a couple more questions?
Are there more questions?
And then call it a night? Yeah, there's quite a few more questions. This one you kind of answered, but maybe we could say again, what literature could you recommend for a deeper dive into Mayan deities, astronomy, and astrology? Of course, you said you have books. You have one coming out, right?
Yeah, there's one in press right now. It's on Chichen Itza and Quetzalcoatl, Kukulkan, Feathered Serpent, and Venus. So that's hopefully coming out in the next few months. But I would recommend things like Anthony Aveni's work on Skywatchers of Ancient Mexico. Alfredo Lopez Austin is a Mexican scholar, and he's got this book, Tamuanchan Tlalocan, which is in Spanish, but has been translated into English as well. So that's a brilliant text to get into religion, cosmology, philosophy. Then he's got another one on Quetzalcoatl called The Legend of Quetzalcoatl that has been translated as well, so you can get that in Spanish or English. Andrea, do you want to throw in any other references on Mayan cosmology and philosophy, religion?
I think the Alfredo Lopez Austin would be a great start.
Yeah, it's a good place to go.
One of the things that I'm always wondering is that maybe you could just touch on the Maya communities today that are, carrying on the traditional culture and language. What is their practical use of like the almanacs and the codices? What is their knowledge of? I mean, and in fact, are they saying, please give the Dresden Codex back? That's our sacred, that's our sacred book, to the Germans. And is there any discussion like that? I mean,
the repatriation issue is a huge, complicated one. What I've found in working in local communities is that it's really kind of an attempt to revivify these historical records. So the books of Chilam Balam, for example, are these texts, these manuscripts written with the Latin alphabet, but they're written in Yucatec Maya. And so I'm speaking to an elder, and we're unpacking how he understands it for his community today. Not trying to say that we're going to now create the canonical, like this is the version everybody should reference, but recognizing that it has meaning to his community that is important in and of itself. And it doesn't have to be something that we then take and publish in academic journals or in the United States for it to be valuable. That returning that knowledge and letting it live on is an important facet of the work that we do.
Andrea, did you want to add anything?
No, I loved your question about bringing the codex back. Like Gerardo said, it's a very complicated issue, especially with Mexican politics, but there has been several attempts to bring it back, and there's already been one codex that was brought back by a student without permission back into Mexico. So yeah, there's hope definitely that we'll be able to bring some back home. But more than bringing the codices back, I think, like Gerardo said, it's really it's such a privilege to be able to have access to this knowledge with how the educational system is in Latin America. Well, I would say in the world, that it's really, I think, a responsibility for those of us that have had access to it to bring it back to Maya communities. And to make it relevant to today's living, as well as what their current life is like now, and what the knowledge that has resisted all these years of of several different attacks on their lives and their culture. Today there's much need in Maya communities to maintain their lives. There's lots of violence and lots of needs happening in so many different communities that I think I wanted to make this call to remember that this is not an ancient culture that's long gone, but it's very much alive and has much knowledge and many needs, and that sometimes we can get very absorbed in academia and the academic world with all these concepts, but it's good to remember that they're here today and that we have much to learn from them.
Yeah, agreed. And that we're living in the era of colonization, post-colonization, right? So it's part of that trauma. So we're all living through that still. Okay, so we're getting late in the time, so I have to do this. I have to share my screen and show everybody where this project page lives. This is a nativeskywatchers.com two-eyed seeing NASA, the Maya project page. So this is what you can do. You can scroll down here. This will change in the next few days, and it'll have this webinar recorded. But I also want to show you there's some other resources here. This is the booklet. The booklet, we put a lot of time into designing this. It goes along with the show, the content that we were just sharing here. So you can download this here, and you can see some of the same information that Gerado and Andrea were presenting here. Don't forget also the last page, which is dedicated to the Indigenous science here, so check that out. Okay, and then I just want to show you as well, we've got the slides. Those are the PowerPoint slides, and then the flyer in English and Spanish, 2 worksheets that were written by Gerardo, and then again, the recording will go right here. Last but not least, I just want to remind you that there are more events, at least 4 more. We've had 2 possible add-ons at the end too, so that hopefully would be happening, but you've got 4 more to look forward to, and our next one is Navajo Dene Astronomy in January. I believe the date is the 29th, which is a Friday, and that's led by our Indigenous elders, Nancy Maryboy and David Begay and their team. So please, I hope to see you again. And I think we're getting over time. So any last closing words, Gerardo and Andrea?
I can't thank you enough, Annette, for inviting us to participate in this. It's a fantastic opportunity. It's allowed me to get back into a lot of material that is just a ton of fun to work with and to collaborate with some absolutely brilliant people here adjacent to me on the screen, but also behind the scenes in the schools. And so I thank you.
Much gratitude for you, Annette, as well as Graciela Rodriguez, Andrea Carrillo, our wonderful maestras from Adelante School, to all the students, to Sabine, to Sophia that were part of this. It's such an honor to be able to weave in our Chumash, our Mixteco family in the central coast of Santa Barbara to bring this Mayan astronomy piece. Thank you, Gerardo. Thank you for this opportunity.
Yeah, Pilamia Miigwech to you as well. And I just want to also say that this is really the foundation, the motivation of this funding, this NASA funding, is for our K through 12 students, and to really give them something during this COVID time that is really so hard on our kids, to give them something extra special and some content that they can relate to, something of hope. You know, that there was great knowledge in our Indigenous astronomy and our connection to earth and sky. So really just want to give an acknowledgement to all those kids out there, the students that are enduring this. And I hope that this programming could give you some kind of hope or some kind of light in the dark tunnel, and that we're going to make it through this together. And the last thing I want to say is thank you to the interpreters, Naira and Ali.
Yes, thank you.
Okay, good night, everyone. Miigwech, Pilamia, gracias. How do you say thank you in Maya?
Dios todo.
Okay. Till next time. Great job, everybody.